All right, so now it's time to talk about equivalent statements and the converse. So what do we mean by equivalent statements? Two statements are equivalent if the following is true. If P implies Q, and if you can reverse it and say that Q also implies P. All right, so let's use an example, no maths, just words, so we can get a sense of what isn't an equivalent statement and then what is an equivalent statement. All right, so here's a statement. If I'm watching Speranza, then I'm learning maths. Again, I hope that's true. All right, let's write the converse of that. We're just going to swap Q, I'm learning maths, with P, I'm watching Speranza. Straight swap, no negations. If I'm learning maths, then I'm watching Speranza. False, right? The reason I say this is false is because you might be learning maths, but you might not be learning maths from me. You might be learning maths from your own teacher, from a textbook, from something else, right? So in this case, these are not equivalent statements. They are not equivalent statements. P implies Q, but Q does not imply P. All right, so we're supposed to be talking about equivalent statements. This is not an equivalent statement. Let's see an example of an equivalent statement. Something like, if your heart is beating, P, you are alive, Q. All right, this is true. Now, if we swap the P and the Q here, if you are alive, your heart is beating, true. All right, so both of these statements are true, so we say that they are equivalent statements, right? This and its converse, right? When we swap P and Q, they are equivalent statements. Done. I do want to make that clear. This is the converse of this, and this is the converse of this. All right, so you will be asked certain types of questions that require your understanding of the equivalent statement, and it is questions of this form here. Now, this little arrow both ways means if and only if. So P is true if and only if Q is true. There's our basic understanding. So let's look at an example of what a question like this might look like in the wild. All right, let n be an integer. Prove that n is even if and only if n plus 1 is odd. All right, so what we have is this if and only if symbol here. We have a P here, n is even, and we have a Q here, n plus 1 is odd. So when you do questions like this, you have to do two proofs. You have to prove that P implies Q. That is, if n is even, then n plus 1 is odd. But you also have to prove Q implies P. So that's the basic idea. We're going to do two direct proofs back to back. So we'll do our first one first, P implies Q. Now when we're proving P implies Q, we have to assume this P is true. So we let n be even, let n equal 2P. All right, so if n is even, P is in the set of integers, okay? And then we write down what we're required to prove. In this case, we're required to prove that n plus 1 is odd, so let's do that. And from here, it's super trivial because we can see that the left-hand side is equal to 2p plus 1. The right-hand side is equal to 2q plus 1. These are both odd numbers, right? We can just say let p equal q, 2q plus 1. The left-hand side equals the right-hand side. And we're done. But we are only half done because we've only proven that P implies Q. And now we need to do just the slightly more difficult one, which is prove that Q implies P. All right, so to prove Q implies P, we need to write down our Q. N plus 1 is odd. Now, let n plus 1 equal 2q plus 1. Where Q is in the set of integers. And we haven't really done something like this before where our assumption, our P, or our hypothesis is like an equation like this. But we can make our life a little bit easier by rearranging this to say that n is equal to 2q plus 1 minus 1 is equal to 2q. You can rearrange your assumption, no problem there. Okay. And now we write down what we're required to prove. We are required to prove that n is even. That n n, which is 2q, sorry, is even. Oh, okay, once again, this is trivially easy to prove because we can now say that left-hand side equals 2q, right-hand side equals 2p. Let q equal p, 2p, done. Left-hand side equals right-hand side. So we have proven that if n is even, n plus 1 is odd. We have also proven that if n plus 1 is odd, then n is even. So we have proven that n is even if and only if n plus 1 is odd. All right, so equivalent statements, PQ, QP, those are equivalent statements if they're both true. This one is called the converse of this one. You might be asked to write a converse statement at some point. And if you ever see the words if and only if, realize that you're not being asked to do one proof, you're being asked to do two proofs. This way, and then this way. That's it.